So this is the Redox longer answer questions, the last question in the booklet, question 3. So the first one, in terms of electron transfer, what does the reducing agent do? So a reducing agent is the substance that becomes oxidised and so loses electrons. But we really want to say what it does to the other substance. So a good way of putting it would be to say that it donates electrons. Loses electrons is okay. Even better if you said loses electrons or transfers electrons to another substance. But therefore reducing it. So as long as you've talked about losing, donating, something like that. And then in B, we've got some oxidation states to work out for nitrogen in a range of different compounds. So it's really worth getting to grips with these because they are relatively easy marks when you get used to it. So we've got nitrogen and chlorine. Chlorine is definitely the more electronegative one there. And so chlorine is going to be -1. Remember, the only time that chlorine isn't -1 is when it's with oxygen or fluorine. So there are 3 of them. That gives me -3. It's a neutral compound, so the N must equal +3. Part 2, Mg3N2. So this time it's the magnesium that's fixed. Magnesium's in group 2, so it's going to be +2, and there are 3 of them. So that gives me +6. And therefore my nitrogen must add up to -6. I will need to give the oxidation number of an individual nitrogen, so that would be -3. So that's one thing to look out for. When we do oxidation numbers, we are doing it per atom. And so each nitrogen is -3. Another thing that I often get asked, does it matter whether you say -3 or 3-? Normally we would use 3- for the charge on the nitride ion. So I'd use that doing a dot and cross diagram. And normally I would use -3 when discussing oxidation states. To be honest, at this stage, it's not really that important, so I wouldn't worry about it. And then number 3, I've got NH2OH. So looking at my hydrogens, they're going to be +1. I've got +2 there, +1 there. Oxygen will be -2. So altogether I've got +3 from my hydrogens, -2 from oxygen is +1, so my nitrogen becomes -1 overall. And so nitrogen can take a range of different oxidation numbers. The most positive it can be is probably going to be +5, and the most negative it can be is -3. But there's a whole range of different things, as you can see. If you bond to hydrogen and oxygen, you can get a variety of different oxidation numbers. Part D then, this is where the half equation really came into play. So for the formation of lead 2 ions and water from lead 4 oxide in the presence of hydrogen. So we've got lots of clues, it's told you to make water. Really the most important thing is the lead 2 and the lead 4. Those are the things that I need to know about starting and ending with. And nicely, they've given us the formula of lead 4 oxide. They wouldn't have to, because you should be able to work it out. So if oxygen is -2 and lead is +4, that's where we're getting the formula PbO2. So in part 1, we have PbO2 on the left, leave a bit of space, and lead 2+ is what is being formed on the right. I'm also told that water is formed, but actually that would be the next thing I was going to do anyway, because my lead is balanced, there's 1 atom of each on each side. So my next thing would be to add 2 waters, because I have 2 oxygens on the left hand side. Now I've balanced the water, I need to balance the hydrogen ions. And again, I can do that because I've got 4 hydrogens on the right, so I need 4H+. And then I'm just going to check my oxidation numbers. Well, I already know it's +4 on the left because I've been told, and I can see it's +2 on the right because it's a 2+ ion. So to get from +4 to +2, I need to add 2 electrons. I can check that charges add up. On the left, I've got 4 H pluses, so +4, 2 electrons, -2, so total charge on the left is +2. And on the right, my total charge is also +2 from the lead 2+ ion. Okay, next part, formation of chlorine from chloride ions. Again, this has got to be in your top 10 lists of half equations you should just be able to write. So make sure you read the question right. It's formation of chlorine from chloride. So I'm going to start with chloride, and I'm going to make chlorine, and I'm going to produce 2 electrons when I'm doing that. So notice that this is only 1 mark. The equation above was 2 marks. It was 1 mark for getting all the right formulae in the right sides of the equation, and the second mark for the balancing. So yeah, you'd only get 1 mark for doing a chloride-chlorine half equation. Notice that I've got 2 electrons on the left at the top and 2 electrons on the right at the bottom. That's really useful. That's what I would hope for, because otherwise, if they were both losing, I wouldn't be able to combine them in the next step. In the next step, it's really easy to put them together because there are 2 electrons on the left and 2 electrons on the right. So they already cancel out. So now I'm just adding the 2 equations together. So don't treat this as something new. We are just putting together the 2 equations we just did. And it says we're in the presence of HCl. So what I'm going to do is write my PbO2. I've got 4 H pluses and 2 Cl minuses, so I can make 2 HCl's from that. And then there are 2 additional hydrogens that get used up. And then my products, I'm going to make Pb2+ ions, I'm going to make chlorine, and I'm going to make 2 molecules of water, and it doesn't matter how you write those, what way round. Don't be tempted to put your Pb2+ and your chlorine together, because that's chlorine, that's not chloride ions, so you can't stick those 2 together. It's also perfectly acceptable to write your 4 H pluses and your 2 Cl minuses separately on the left with your PbO2, so that would be acceptable as well.